So this problem says, it gives us integral of sine squared x times cosine to the 6th x dx. Alright, so what we're going to do here is use the property that sine squared x equals 1 minus cosine squared x, right? So what we actually get is a 1 minus cosine squared x times cosine to the 6th x dx. And then what we can do now is distribute this term into both, right? So then we get a cosine to the 6th x minus cosine to the 8th x, and then our dx out here. Okay, so this is kind of, this is like a two-part thing. I'll think of this as 1, right? I've done this in a previous problem as well. And then minus, this is like part 2, okay? Because these are going to get kind of lengthy. Alright, so as far as 1, I'll solve that one first. So, for cosine to the 6th x dx, we're going to use the reduction formula, which, again, is on page 419. Reduction formula. Okay, so basically, once you apply the reduction formula, we're going to, I guess I'll write all of them out. It's kind of long, so I'm sorry beforehand. But, yeah, so the first thing is going to be this, cosine of the 5th, sine x. And then once you do this multiple times, you'll start to see a pattern. Yeah, if you can't see it in the formula already, then you'll see it as you're writing it out. Okay, so that's that. And then you apply it again here. So then our next line is going to be, everything in front stays the same. So 1 over 6 cosine to the 5th sine plus, and then we have our 5 over 6, which stays out here, and then we're going to have a 1 over 4 cosine to the 3rd x sine x plus 3 over 4, that's a 3, sorry. And then integral of cosine squared x dx. Woo, that was a weird bracket, hold on. Okay, that's better. Okay, so then we have that, and I'm going to go on to the next page and write the next line. So then, like I said, everything in the front that we've already integrated in a sense, that's just going to stay the same. So cosine of the 5th and normal sine plus, now I'm just going to distribute the numbers that we had before. So that's 5 over 24 and cosine to the 3rd and sine x. And then when you integrate the cosine squared x, we're going to apply the double angle formula, which can also be found in your book and on the previous concepts video. So yeah, so this is actually going to turn out to be something like 24, and then I'm just cutting down on the math here, because from here on out it's just trig stuff. So cosine x sine x, and then we have a plus 1/2 x, and then of course our plus c, because this is indefinite. Okay, so our final, alright, yeah, I guess I'll write out, yeah, so this is what we have for equation 1, kind of, sort of. So this was equal to cosine to the 6th x dx, integral of that, right? So this is equal to that whole top line, alright? So now, let's work on part 2, and this is an even bigger one, bigger power. So we have cosine to the 8th. Alright, so let's start. We're going to use the reduction formula. So we actually get something that looks like 1 over 8 cosine to the 7th, and then sine x, plus the remaining 7/8 kind of thing. And then in here we still have a cosine to the 6th x dx. Okay, so I'm going to stop here, just because I want to point out that what we have obtained from the reduction formula, this integral cosine 6x, cosine x to the 6th of dx, that can actually be utilized as well. Like, we're just going to plug in this entire line for that spot. So let me walk you through it on the next slide. So this is what we got for equation 2. So keep this in mind, all right? Okay, so here we go. Our total equation, so this is the thing that we started off with, right? And we got to a certain point where I said 1 minus 2, like equation 1 minus equation 2. So this was, it looked like this, and then minus the cosine to the 8th x dx. Okay, so what we had here was equation 1, okay, and then this was equation 2, kind of a thing. Alright, so then when I plug in what we've obtained, so this cosine to the 6th dx minus, and then let's plug in what we got for the cosine, integral of cosine to the 8th. So we actually get, this is a minus 1 over 8 cosine to the 7th x sine x, and then plus 7 over 8, and then we have our cosine to the 6th x dx. Okay, and so you can kind of see what's happening here. We have this term and this term, and they're actually like terms, okay? So this is like a 1 in front, right, minus 7/8 of the same thing. So this actually turns into a positive 1/8 of cosine to the 6x dx, right? When we combine those like terms. And then we still have, distribute the negative inside here, cosine to the 7th x sine x. Okay, so from here, and this is going to be really long, and again, I apologize, but remember about two slides ago, I think, or the previous slide, we found a long line for this integral. So we're just going to plug that in right here, and that's going to be our final answer. So I'm going to try to squish this in. Alright, so I'm going to move this in front first, just to get it out of the way. Negative 1 over 8, and then the cosine, oh, that is not, okay, hold on. Okay, so cosine to the 7th x sine x. So we got this part taken care of, and then we can add it to 1/8 of the long line. Okay, so it's going to be a 1 over 6 cosine to the 5th x sine x plus 5 over 24 cosine to the 3rd x sine x plus a 15 over 48 cosine x sine x, almost done, wonder if I'm going to get it, plus 15 over 48 x. Okay, so that was all, and then can't forget the plus c at the end because it's an indefinite integral, no bounds. Alright, so this final thing here is our answer. Yay! Okay,